Okay, this video tutorial looks at the mathematical strand of polynomials, and more specifically we're going to focus our understanding on the definition of polynomials and also looking at some operations involving polynomials. So I guess we need to start by understanding what exactly a polynomial is. So essentially it's just a function that can be written as the sum of terms, basically where we have integers to a power and variables to a power where those powers are positive. All right, so as an example, you can see in our first one here, p of x, we've got 3 to the power of 2, and x is obviously to the power of 1, being positive, which is great. You can see in our last example where 3x is to the power of -1, which is obviously not a polynomial because we can't have it to a negative index. And also in our third example here, you can see that the power is actually a variable, not a number, all right, or a numeral, so we can't do that. And we can see here in our second example that the power is a fraction, which is not an integer or a whole number. Okay, so it's basically a bunch of terms where the power is a whole number and the power is also positive. You can see here the degree of the polynomials is basically the highest power of the variable. So if we're looking at x, it's usually the variable we use. We can see that linear is when x is to the power of 1, okay, 1 meaning linear. Quadratic is 2, so obviously the x is to the power of 2. When the x is to the power of 3, it's a cubic. All right, and when x is to the power of 4, it's a quartic. Okay, so the degree of the polynomial is basically the largest power of the variable. And just a reminder of some language when we're looking at mathematics. The last term, basically, the term without a variable, is known as the constant term. That should not be new information for you. Okay, so if we look at the example down the bottom, it says the polynomial f of x, all right, has a degree of 3, and it's got a degree of 3 because the largest power of the variable is 3, and it has a constant term of -5 because that's the last term, or the term at the end without a variable. When we're looking at adding and subtracting polynomials, basically we just add and subtract by collecting like terms. Now, collecting like terms, all right, should be something that's relatively familiar. It's one of the earlier concepts introduced in algebra. And here are a few examples. So if we've got the function of p of x, all right, is x to the power of 3 plus 2x to the power of 2, take 4x plus 3. And we've got the function of q of x, where q of x is equal to 5x squared plus x, take 2. We can simply add and subtract these. So in p of x plus q of x, we're just going to add the like terms. And you can see that the like terms, we've got a 2x to the power of 2 and a 5x to the power of 2. We add them, we get 7x squared. We've got a -4x plus x gives you -3x. All right, so that's our next like terms. And then the last constant term is 3 take 2, which is just going to give us 1. Now we just do the same thing when we are taking away. All right, essentially when we are taking away, I guess in all the terms in q of x that are positive then become negative, and all the negative terms become positive. So we would see that our first set of like terms, we've got, instead of adding x, we're taking, instead of adding 5x squared, we're taking 5x squared. You can see that instead of plusing x, we are actually minusing x, or taking x away. And the last term, you can see that we are actually adding 2 instead of taking 2. And you can then see our answers of adding and subtracting down here. So it's simply just collecting like terms. When we multiply a polynomial by a constant term, okay, an integer, we basically just multiply each term of the polynomial by that integer or by that number. So a good example to use, there's a couple examples here, but I'm going to use the first example. So if we've got 2 lots of p to the power of x, or p to the x function, we're basically timesing everything, all the terms in P by 2, and there's our answer. All right. So remember, whenever you're timesing a function by a constant, you just times every term or multiply every term in that function by that constant. Now, when we're looking at multiplying polynomials by polynomials, we basically multiply each term of the first polynomial by each term of the second polynomial. So this is really just an extension of expanding brackets. All right, where we just need to make sure that we multiply every term in the first function by every term in the second function. Once we've done that, we can collect like terms, and that's what's happening here. All right, we're just collecting like terms and then simplifying our expression. Now, dividing polynomials by a polynomial is a little bit more difficult. Okay, we essentially follow the same rules as basic long division. So you can see in our first example where I've just put a red asterisk, this is a long division problem where we are dividing 5,879 by 13. We essentially see step 1, find the largest possible multiple of 13 that's less than or equal to 58, because 58 being the first double-digit number in 5,879 when we are doing our long division. And you can see the process over here. All right. So we've obviously gone 413 to 52. Okay, we found our 52. 58 take 52 gives us 6. We bring down the 7. We've now got 67. All right. Then 13 times 5 gives us 65. We take 65. We bring down the 2. That gives us 29. We then have 13 times 2 gives us 26. And then we have a remainder of 3. And that is how we get here. Okay. And obviously, the 4, the 5, and the 2 are what make up 452. So we follow the same rules when we are dividing a polynomial by another polynomial. We're simply looking for a multiplier that'll get us to our first term in our original polynomial. So we've got x plus 2 here, but our first term is 3x cubed. So what do we multiply x by to get 3x cubed? Well, that gives us 3x squared, which is why 3x squared becomes our first term. So we're essentially, you can see that in step 2 here, we've multiplied by 3x squared to give us 3x cubed plus 6x. We are then taking away. We then bring down the 10x and we do the exact same thing, bring down the 9 to the exact same thing and get to our remainder. Okay, so the remainder of 5, we end up with our result up here, or our quotient. And then remember that our bottom number in our fraction that we're dividing by is our divisor. So there's some important words to consider when we're looking at dividing polynomials by polynomials. Okay, so once we've had a bit of a practice at dividing polynomials, you'll probably discover a generic formula, which is in this green box here, where our original function of x divided by our divisor, in this particular case ax plus b is your generic divisor, will equal the quotient of the function plus the remainder divided by our divisor. Okay, so if we can see here, we've got our divisor, which is x take 3. Now that's going to give us our quotient, if we follow our long division steps, and our remainder. And so, in this particular case, p of x divided by, or instead of, oh well, we can just write this, x take 3 is going to equal q of x plus our remainder, which is 19, and I don't know what all this is yet because we haven't done it, even though the example's there. So then we can rewrite this and go 2x cubed take 5x squared plus x plus 7 is going to equal, all divided by our divisor, x take 3. It's basically equal to 2x squared plus x plus 4, all divided by x take 3, sorry, I've written that wrong, plus our remainder, 19 divided by x take 3. And there's a way you can check this answer. So if you think you've got your quotient correct, here's a way that you can check it. If we've got 2x squared, because that's our quotient, plus x plus 4, and we multiply that by our divisor, and then we add our remainder, we should end up with the original function that we had at the start. So this becomes 2x cubed plus x squared plus 4x, take 6x squared, take 3x, take 12 plus 19. I collect the like terms. Alright, so we've got 2x cubed, I've got an x squared there, but I'm taking 6, so that gives me minus 5, x squared. I've got 4x, take 3x, which just gives me plus x. And I've got negative 12 plus 19 gives me positive 7. And as you can see, that's the original function that we had at the start. So that's just a way you can check, get your quotient, multiply it by your divisor, and then add your remainder. So something just worth thinking about is, obviously when we're dividing polynomials, we sometimes might need to figure out the multiplier, but we may have to use a negative to do that. Alright, so just making sure that when you are multiplying to get a 0 to do your long division, you may need to use a negative multiplier. Alright, so just keep that in mind. Okay, so here are some practice questions I'd like you to have a go at. Please feel free to pause the video. When you think you've got them correct, continue the video and we'll see how you went. Okay, so let's see how you went. If we're going to add these functions, we're going to have x squared plus 1, which is our px, plus 2x squared plus 3x, take 4. We're just simply collecting like terms. So this becomes 3x squared plus 3x, take 3. And if we are subtracting, we've got x squared plus 1, take away 2x squared plus 3x, take 4. Now remember, the negative out the front turns all those other terms into the opposite of what they are. So this becomes negative 2x squared, take 3x plus 4. We simply collect the like terms. This becomes negative x squared, take 3x plus 5. Okay, so for our second question, we're just multiplying these two. So we have 4x cubed, take x squared plus 2, and we're going to multiply that by x squared, take 5x plus 4. I'm going to multiply these first, which will give me 4x to the 5. Then I'm going to multiply the 4x cubed by the negative 5x, which is going to be negative 20x to the power of 4. And then I'm going to multiply it by the last term, which is going to be plus 16x cubed. I'm then going to multiply my middle term in my first function by every term after that. So this will become negative x to the power of 4, positive 5x to the power of 3, negative 4x squared. Then my last term, I've got 2x squared, take 10x, and my last one will be plus 8. I then collect the like terms. So we've got 4x to the power of 5 minus 21x to the 4, because I've got one there and one there. I've then got plus 21x to the 3, there and there. I've then got minus 2x squared with here, collecting that, take 10x plus 8. Okay, so let's see how you went with this last one. So our divisor, x take 4, I'm going to divide that all into x cubed take 9x squared plus 6x, take 7. Now the first thing I need to do is find the multiplier to get x to the power of 3. So that becomes x squared, x take 4. So therefore this becomes x to the power of 3 take 4x squared. And I'm going to take that away, which is going to make that a positive 4x squared. So we've got x squared as my multiplier, and this becomes negative 5x squared. I'm going to bring down the plus 6x, and now I've got to find my multiplier here. It becomes negative 5x. This becomes take 5x. So this becomes negative 5x squared plus 20x. I'm going to take that away, which is going to give me minus 14x. Okay, I'm going to bring down the negative 7. So now I've got x, take 4. I need to make it minus 14. Minus 14, that's going to give me minus 14x plus 56. And if I'm going to take that away, I'm going to end up with negative 63 as my remainder. So this is going to equal x squared, take 5x, take 14, take 63 over my remainder, which is, my divisor, which is x take 4.